Hello and welcome to this video that goes through question 13 of M1A of the Madas papers, or MP1. So this is the first AS level paper. So in this situation, this is quite an interesting question. We've got log base 2y minus 1 equals 1 plus log base 2x, and then 2 log base 3y equals 2 plus log base 3x. The issue with this question is the fact that both equations have different bases. Now, one way that we could do this is we could convert all the bases using a base conversion, so that they're all the base. So for example, you might convert log 2 log base 3y into base 2. However, there is actually, what we could also look at is we could just try and get rid of the logs, and this will work because we have one value, the number here, which is the only thing that's not a log. And because this number is very nice, we can actually convert it. So if we think about what this actually means, if we do log base 2 of 2, if you plug that into your calculator, that is equal to 1. And what this basically says is that, well, in terms of the inverse of this is like 2 to the power of 1. So 2 to the power of 1 is equal to 2. So if you did base 2 on both sides, so essentially it's telling you that, so here 1, the conversion in terms of 1 is equal to, in something log base 2, well, log base 2 is equal to 1. Essentially 2 to the power of 1 gives you 2. So again, it's the power of the base that we're interested in. So if you take 2 to the power of 1, because the base is 2, then that gives you your 1. That's equal to 2. So that's what gives 2 essentially. So what does that mean? Well, that means that we can make a conversion, and we could say that's log base 2y minus 1 equals log base 2 of 2 plus log base 2 of x. Now this seems a bit counterproductive. Why we made it worse, but we haven't, because we made it easier, because now we can use our log rules to solve this and get rid of the logs. So here we're going to have log base 2y minus 1, and then we're going to use the log rule, where it's log a plus log b equals log ab. So on the right hand side, therefore, we've got log base 2 of 2x, and then this allows us straight away to get rid of our bases. We take base 2 on both sides, so we're left with y minus 1 is equal to 2x, and then we can go back to our second equation here. So we've got 2 log base 3 of y equals 2 plus log base 3x. So here we're going to do a similar approach, and in terms of, we're going to get rid of a 2. So here we want base 3, so we want to work out what does 2 equal. So essentially that's going to equal 9, because 3 squared, so 3 squared is equal to 9, so therefore log base 3 of 9 is equal to 2. Okay, 3 to the power of 2 gives you 9. So the log base 3 of 9 gives you 2. That's basically telling this equation, this part here is basically asking what's the power, what do I put 3 to the power of, so whatever is that power of, that gives me the number inside the log. In that case it's 2. So that means we can do the replacement, so it's 2 log base 3y is equal to log base 3 9 plus log base 3x. We can use the log rule we've just used, the log a plus log b equals log ab rule on the right hand side. So that gives you log base 3 9x. On the left hand side, we're going to use the rule log a to the power of b is equal to b log a. So here we're going to move the 2 across. If you want to get rid of the logs, which is our goal here, we need to remove any numbers in front of those logs. So here we're going to end up with log base 3 of y squared, and here we can cancel the logs, and we get an equation y squared equals 9x, and then we've also got y minus 1 is equal to 2x. From here we can then do a quick substitution, so y is equal to 2x plus 1, and therefore y squared is equal to 2x plus 1 squared, and then we can substitute that into our equation here, so it's 2x plus 1 squared equals 9x, 4x squared plus 4x, is 4x plus 1 is equal to 9x, and that gives 4x squared minus 5x plus 1 is equal to 0. From here on your calculator, just go to equation of function, polynomial degree, and we've got 4 minus 5 and 1, and we get 2x values. X is equal to 1 and x is equal to a quarter, and then we can plug that into y because we have y equals x plus 1. That's 2x plus 1, sorry, just checking, so it's 2x plus 1, I have done it correctly, so therefore it's y equals 2x plus 1, so y is equal to 2 times 1 plus 1, so y is equal to 3, and y is equal to 2 times a quarter plus 1, so 2 times a quarter is a half, plus 1 is y is equal to 1.5. One thing we also need to do is we do need to check the logs, because we need to check that it makes sense, because some log rules don't work. So if we need to go back into the equation, now the reason why is that if you look at a log graph, so this step is actually really important. In this case it's not actually going to be as critical because of our values, but remember for a log graph, we have a log graph looks like this, so we don't have certain x values, that makes it impossible. So essentially you can't have a negative in terms of inside the bracket. So for example, if you type in log base 2 of minus 1, for example, that would give you an error. So here the only thing we need to really worry about is the y minus 1, because our x and y terms, every other term is above 0. We've got y minus, so log base 3 y minus 1, doesn't really matter what the base is, but here when we plug y in, we get, in this case here, we're going to get log base 3 of 2, and then we get a log base 3 of 0.5. So therefore all values are fine. Now in some cases you don't necessarily need to do it in this case, but there will be cases where, for example, you might have like y equals 0.5, well that's not a valid value, because that would give you, in this case, y minus, where 0.5 minus 1 gives you minus 0.5, which is not possible, so therefore this would not be a possible solution. But in this situation it's completely fine, and that is the question. Any questions, please let me know.